Hello and welcome to my channel. In this video we are going to learn how to solve some exam style questions on definite integrals as well as understand what definite integrals are. Definite integrals are a part of integration. I have explained about indefinite integrals in the previous video uploaded. So if you are interested to understand the basics of integration and indefinite integrals, you can click on this link above. Now let us look at definite integrals. Definite integrals means the limits. That is, if I am going to draw a curve, for example this is a curve which is somewhat like this, and I want to find the definite area between this point and this point. For example, let me take this point as 2 and let me take this point as 5. So I want to find out what is the area below this curve. So since the area is definite, we call it as definite integrals. And the definite area is in between two definite points, that is 2 and 5. These two definite points we call it as limits of integral because they tell us from which point till which point we should be calculating the area. Now we are starting at point 2, so we call this as a lower limit, and the highest point till which we are going to calculate the area, we call it as the upper limit. And this curve, for example, in this case it is taken as x cube, so this curve is nothing but x cube function, so we can write it as y equal to x cube. If you want to find where its applications are, then you can find out the acceleration in the speed time graph or velocity time graph, or if you want to find out the displacement under the curve, then you can obviously go for the integration. So this is how we relate the physics to the calculus. Now let us see how exactly we are going to solve this integral. Since the lower limit and upper limit are given along with the integration, we call it as a definite integral. If the upper limit and lower limit were not given, if it was written as x cube dx, then it would have been indefinite integral. Now let us see how we are going to integrate this function. Now x cube. In the previous video which I have uploaded on indefinite integrals, I have discussed a formula there where integration of x to the power of n dx when integrated could be written as x to the power of n plus 1 over n plus 1 plus c. This c is constant of integration which exists in case of indefinite integral if the limit is not mentioned. But since here the limits are mentioned, this c need not be written. But the rule remains the same, that is the power of x will be incremented by 1 and the same power should be written in the denominator. So taking this formula into consideration, you can see the same formula is applied. X cube, here the power of x is incremented by 1, so it has become x to the power of 4, and the same power is repeated in the denominator. And once we have integrated the x term, this integration sign disappears and we can replace it with a line, with a straight line mentioning the upper limit and the lower limit. You can also write a square bracket. In some of the books they have mentioned the square brackets, or you can just put the straight line. Next, after doing this, we need to substitute the values of upper limit and lower limit in this integrated form. So here I have taken 1 over 4 common out, and inside the bracket 5 is being substituted in place of x. So 5 inside the bracket raised to the power of 4 minus, now write the lower limit in place of x. So 2 to the power of 4. Remember to put the brackets. It makes a lot of difference if you do not put it, especially in case of negative limits. So this is upper limit minus the lower limit. After substitution, we have to just check what answer we get. This is 1 over 4. 5 raised to 4 is 625 minus 2 raised to 4 is 16. So after subtraction, we are going to calculate the value of the integration. So this means that the area under this curve is given as 152.25 units. So no need to mention the units here for the area because the units are not given, only the limits were given. So we can just write it as 152.25. That is the area under the curve. So this is how we find the definite integrals. Next we have in definite integrals as fundamental theorem of calculus. It says that if we are taking an integration of a differentiated value or a function, f dash of x is a differentiated function. So if f of x was a given equation, we have differentiated it with respect to x, and that has given us f dash of x. Remember, these are different ways of writing the differentiation. Sometimes they even give it as y dash, or they also give it as y dash of x. So these are all different representation of differentiation. So here it says that if we are integrating a differentiated function of x within the intervals a to b, then we have f of b, that is the function from point b till the point a. So here we can consider this as point a and this as point b. That is, this is lower limit and this is upper limit. So whenever we are using fundamental theorem of calculus, it always becomes upper limit minus lower limit. This is what was shown over here, upper limit minus lower limit. So remember the fundamental theorem of calculus, it becomes really easy to solve the examples. Now let us quickly look at some exam style questions. Given that k is a constant and the definite integration of 1 till 4, 6 root x minus k dx is equal to k square, show that there are two possible values for k and find these values. So this is for 5 marks. So let us see how to solve. Now this is a definite integration, that means we have the lower limit and we have the upper limit given to us. So let us write it down again. Integration of 1 to 4. So we have 6 root x minus k dx is equal to k square. This is what is given. Now what we will do is we will start integrating the left hand side and see what we will get. So we are going to integrate it as, let me change the power of x and write it as half, because x to the power of half is nothing but square root of x minus k, and this is integrated from 1 till 4 and this is dx. Now I'm going to independently integrate it and write it as integration of 1 to 4, 6 x to the power of half dx minus integration of 1 till 4 k dx. Now here we can integrate it as 6 is a constant, so I can take it out, and integration of x to the power of half. Here we are going to use the same formula, that is x to the power of n plus 1 over n plus 1. So the power of x is incremented by 1. So here we write it as x to the power of half plus 1. The same power repeats here, half plus 1. Remember to put the limits, that is from 1 till 4. Now in this case k is a constant because here it's mentioned, and we know that the integration of a constant gives us k times x. So we are going to integrate it as 1 and till 4. Now let us simplify this. We have it as 6 x to the power of 3 over 2 over 3 over 2, and the limits remain the same, 1 till 4, minus kx, let us write the same thing, till 1 till 4. Now 6 divided by 3 over 2 gives us 4, x to the power of 3 over 2, 1 till 4, minus kx 1 till 4. Now comes the substitution of the upper limits and the lower limits. So we can write it as 4, keep it out because it's going to be common. Now first we are going to substitute the upper limit. So it becomes 4 raised to the power of 3 over 2 minus the lower limit. So we are going to substitute 1 in place of x. So 1 to the power of 3 over 2 minus, here k, we are going to substitute 4 in place of x. So 4 minus, in place of x we are going to substitute 1. So let us solve this and see what we will get. So 4 in the bracket, 4 to the power of 3 over 2, and then we have minus 1, because 1 raised to anything will be 1 itself. Then we are closing the bracket, so we get it as 28. So the value of this function, we got it as 28 minus k, 4 minus 1 is 3, so minus 3k. This was given equal to, in the equation, k square. So the solving of this part we have reached till this point, 28 minus 3k, and this has to be equated equal to k square. Now if we look at it clearly, this looks like a quadratic function. So let me rearrange it and write it as k square minus becomes plus, when we shift then minus 3k over here, so plus 3k minus 28 equal to 0. Now they have clearly mentioned in the question to find two possible values for k. So we can use the quadratic formula over here, which is given as k equals minus b plus minus root b square minus 4ac divided by 2a. So here we have a is equal to, the coefficient of k square is 1, so 1 here, b we have 3, and c we have minus 28. So let us substitute and check what we get. K equal to minus 3 plus minus square root of 3 square minus 4 into 1 into minus 28. Whole thing divided by 2 times 1. So let's solve this first and see what we will get. It is minus 3 plus minus, let us see the square root, what answer it gives us. So 3 square is 9, 3 square minus, in the bracket, 4 times 1 times minus 28. So we get it as 11. So the square root value is 11. So we can just write it here as 11 over 2. So we have got two values of k now. Let me take it as k1 once, when we take the symbol here as plus, 11 over 2. And let me take another one as k2, where I take minus 3, and in between I'll take minus 11 over 2. So here I have it as minus 3 plus 11 is 8 over 2, which gives us 4. And here minus 3 minus 11 gives us minus 14 over 2. So it is minus 7. So these are the two values of k. So this is how we find out the integration or definite integration of this given function. Then use algebra, that is quadratic equation, to solve and find the two values of k. Now let us look at another exam style question. Evaluate integration from the limits 3 to 9 of the function 2 over root x dx giving your answer in the form x plus y square root 3, where x and y are integers. So they want us to evaluate this integration. So let us start by writing the limits, and 2 over, now square root of x, I am going to write it as a fractional power, so x to the power of half dx. Now the next thing I'm going to do is I'm going to pull this x to the numerator. So integration between the limits 3 to 9 to x to the power of negative half dx. Since the x moved from denominator to numerator, its power has become negative. Then I'm going to integrate it, and the integration becomes, for x to the power of minus half, we get it as minus half plus 1. The power is going to increment by 1, divided by minus half plus 1. And since these are definite integrals, we are going to write the lower limit and upper limit. 3 is the lower limit, 9 is the upper limit. So let us further solve this. So this becomes 2. X to the power of half plus 1 is half, divided by half, and this becomes 3 and 9. So 2 divided by half gives us 4. X to the power of half, then the limits will stay as 3 and 9. Once we have got this, we have to just start substituting the values in the place of x. 4, and then we are going to put the upper limit first in the x place, 9 to the power of half, minus, then we are going to put 3 in the place of x, 3 to the power of half. So let us see what we will get. So we'll keep the 4 the same way, and let us check for 9 what we get. 9 to the power of half, we get it as 3, minus 3 to the power of half is nothing but square root of 3. Remember, do not write this in decimals because they want the answer to be in the form of a surd, x plus y root 3. That is why we are not changing the answers to decimals here. Now opening up the bracket, 4 times 3 gives us 12, minus 4 times root 3 gives us 4 root 3. Now this resembles the format they want us to get, that is x plus y root 3, where x and y are integers. So here by comparison we can see in place of x we have 12, and in place of y we have negative 4. So these are the two integers to be found. Hopefully you have liked the video, and if you're liking my videos, like, share and subscribe to my channel, and thanks for watching.